Is this visible for everyone?
Yes, sir.
Yes.
So, uh, as I mentioned, we are supposed to start acceleration due to gravity. Uh, what is this? Huh. New topic is acceleration due to gravity. It is one of the easiest topics you always feel comfortable about. Acceleration due to gravity. And I think as of now we are doing more chemistry in the general like evening class. I will increase one more class for physics and one biology. I think slightly we should have like otherwise we'll lose complete touch. Even if it is for short interval, we'll do biology. Okay, but only short interval, not to lose complete touch. What is today's date? 2012, 2025. When we talk about the acceleration due to gravity, Earth attracts the body toward it. Correct. So Earth is pushing the body or pulling, Jordan?
So it's pulling the body.
Yes, Earth pull every object toward it. Correct. Toward it means what? Toward the center. Correct. Every body, if you have in the depth, it will try to go toward the uh, center. Correct. So what is this force? We are saying ki, Earth pull. Pull means it is exerting
It's an
force.
attractive force.
Yes. So this pulling force, what will be the amount? Sarah, if mass of the body is m, correct? Force is equal to mg. What is the difference between these colors? Wow. So force is equal to mg. What is the difference between these color, guys? Yeah. Okay. So force is equal to mg. Chandana, what is the force if you compare with the this gravitation field? What is the force in gravitation field, Chandana? You know, gravitation field intensity is the force acting on per unit mass. Can we say force is equal to mass into gravitation intensity? Chandana, I think you have network issue. Your voice is breaking. So, if F, F is equal to mi because gravitation field, and you can compare this with the uh, electric field also because in case of electric field, it is the force exerted on unit charge. Here it is unit mass. Correct? That's why in electrostatic force will be equal to charge into electric field. Same here, mass into gravitation field. Correct? If you compare these two, like if you compare this force is equal to mg, we know according to Newton's second law. This is F is equal to mi according to the gravitational force. If you compare these two, can we say From equation 1 and 2, from equation 1 and 2, can we say mg will be equal to mi, cancel? Can we say g will be equal to the I, at least in the magnitude? Yes or no? Any doubt, guys?
No, sir, no doubt.
If you know this, कि G value is equal to gravitation field intensity. So same thing will be here. कि we know gravitation field intensity is equal to G m by r square for Earth, because capital M is the mass of Earth and r is the radius of Earth. Correct. Same way, G value of Earth will be equal to same mass of the Earth and radius of the Earth. Correct. And when we put all the value, G value 6.67 into 10 raised to power minus 11, mass of the Earth and radius of the Earth. What is the mass of the Earth approximately? Radius is approximately 6,400 kilometers. Mass of the Earth is equal to 6 into 10 raised to power 24 kg. No need to remember this data. Correct? It is very heavy. You can compare just with the number. And Z value we already know. So if you put all the value, Pratigya, what will be G value? Pratigya, what will be the G value?
9.8.
9.81 is the precise value, but still in most of the situation, we take 10 for the convenience. But remember, when see this number is easy, okay, this is the value. This is the value only for the Earth. If you change the planet, then this G value will change. Correct? This G value will change if you change the planet. Sometimes it is given in the term of the density, because sometimes you don't have mass, you have density and volume. You can write in term of density. You know density is equal to mass by volume. So mass will be density into volume. Sarah, mass is equal to density. What should be the value of the volume? Sarah, are you
Uh,
there?
yes, sir. Yes, sir.
Yeah. Volume of the sphere, because Earth is a sphere.
Yes, pi r square.
4 by 3 pi r
Pi
cube.
square
Volume. 4 pi r
into
square area, and volume is 4 by 3 pi r cube. Correct. So you can put value. You have mass value, so G value will be equal to Gm by r square. Gm value is equal to 4 by 3 rho pi 4 by 3 pi r cube into density, and below you had r square. So r square will be cancelled out with this, and your G value will be equal to 4 by 3 pi G R rho, because most of people will focus on G is equal to G m by R square. But if you revise this and correlate with it, your calculation will become fast. I'm not saying like you can't do this. You can definitely do this. This is easy topic. But the point is whether you can make it fast or not. Okay. So if you say
One question.
yes, Jordan.
So if you're solving for G, so it can be like simplify pi into three, like into one, because pi divided by 3.1 divided by 3 is almost equal to 1. So if you're solving it, can we just take it as 4 into G into R into rho?
Yeah,
Okay, sir.
but what is the more important? If you take in the mass term, then G is inversely proportional to R square, correct? But if you take in the density term, then G is directly proportional to R. This is interesting. Make sense? So it's really important what you are taking. If density is taken, directly depend upon R. If mass is taken, inversely depend upon R. It's clear. Okay. And people will consider mostly G inversely proportional to R square and they will calculate. But remember what is given in the question. Okay. What is given in the question. This is really important before considering how you want to solve. Let's do one question. Then you will understand. Question is the density of the planet. Density of a planet is double of density of Earth. Of density of Earth and radius is, make it fast because this is very easy question. 1.5 times of Earth. What will be the acceleration due to gravity? A value of the planet. How many times of Earth?
So 3 times?
3 times. Okay, anybody else put answer? Solve it. Make it fast.
Good morning, sir.
Good morning, Gurinder. So, everybody got answer 3?
Yes, sir.
Answer will be 3. Why? Because remember here you have to consider density and you have to consider radius. Two factors. If you consider these two, then you know G value of any planet will be 4 by 3 pi GRP. Correct? So we can say G value directly depend upon R and rho. Right? So G of new planet compared to the G is radius is 1.5 times and density is 2 times. Done. Delta Z dash will be 3 times of the. Was it extremely easy, guys? Any doubt?
No doubt.
Yes.
Sometime you get question numerical. This is only for the numerical purpose, not no theory in this topic. Sometimes you get the what is the percentage change in the gravity? Percentage change in the gravity. So this part become little tricky because you already know two formula. G is equal to Gm by R square, or G is also equal to 4 by 3 pi GR rho. Correct? If change is less than if change is less than 5%. So what will happen in this case? Change is very less. So overall value there won't be much difference. Example based on this, you can say delta G by G, whatever in the numerator it will be plus and denominator will be minus. So delta M by M and power will be the multiply. So 2 delta R by R. Why we are not taking G? Because G do not change. What can change in this system? Mass can change, radius can change according to the situation. But G value is always fixed. Okay. If you have numerator, it will be plus. Denominator, it will be minus. Power will be multiplied. In case of M, power is 1. That's why it is 1. But in case of R, power is 2. That's why you are multiplying with 2. Tell me, guys. Anybody have doubt in this?
Sir, but in unit and measurements, we took denominator as plus.
That we were calculating the percentage, right?
Yes, sir.
In unit and dimension, when we were discussing, then percentage change in no, that was different thing. Ki value was given in the formula and then percentage was given. Here you don't have a percentage, right?
Yes, sir.
Right? Wait, let me. Uh, in unit and dimension, there used to be like A cube, B square, C, D, 4. And we were supposed to calculate what? Percentage change or what?
Yes, sir.
And we
I think
used to 3
percentage.
of the in the percentage, B value given, then percentage, C value given, then multiply with percentage, and we used to add percentage. Correct? Yeah, I got your point. So that was correct in the unit and measurement. When we see here, what will you do is numerator addition and denominator subtraction in overall value. Mm, Let me check. Wait, let me see some question. What we did in the unit and measurement. Nihal. Nihal. Unit and measurement. Let me see the exact question. What we used to do there. This in an experiment that was percentage of error occurred in the measurement is ABC is maximum per that was error percentage,
Yes.
correct? Only for the error. This is actually good observation key. In both situations it is same, then why we are calculating? Because you know in case of error, whether it is addition, subtraction, or multiplication, or division, everywhere you will always add error. Overall value we are not adding, only error we are adding. Understood?
Yes, sir.
Anybody have doubt in this? Why in this case we added all the value in this situation? But sir, you are telling in case of gravitation, denominator is minus. Why you are discriminating? Anybody have doubt? Pratigya,
No, sir.
Marinder,
No, sir.
Jordan,
No, sir.
Sharon?
No.
Because in case of error, even if you take a minus value, error is always added. Example, if here you take this 2 delta A by A plus 1 by 2 delta B by B. For C, it will be minus 1 by 3 delta C by C. And for D, it will be minus 3 delta D by D. Value will be same manner, but error is added. So rule remains same for both the situation. Artha itta Chandana.
ಆಯ್ತು sir.
So even situation is same, but error is added. Only error. Come to this. So who will tell me? Jordan, tell me how will you write this percentage change in case of this formula?
So percentage change. So I mean, we could write the whole formula into 5 by 100 and then subtract it from the actual formula. That's what I would do. If the change is less than. Otherwise, you could just say
5%.
90 by 90.
Now, based
Ah,
on what we did in the first formula, delta G by G, delta M by M, minus delta R by R. How will you write for the second, like,
so
percentage
5%
change?
change for the whole thing, no? Then we'll have to multiply 5 with all of the variables,
No, no,
no?
less than 5%, we don't consider. Example, if dissociation constant is less than 5%, we ignore the small change. That is the meaning, not meaning
So
like
then we just
we
write the
have to add
formula as
5%.
itself. So, okay, so
So tell me
the
what will be
less
the
than
value?
5%, just the delta G is equal to delta G by G is equal to delta capital G, delta capital R, delta capital rho divided by G, R, and rho because all of the values
I,
will be same now.
Jordan, I told you G value is universal constant. Delta G never change. Correct? That's why even in the first formula we didn't write the change.
So then it will just be delta R and delta rho divided by R by rho.
Yes.
Good morning, sir. Sorry, I joined late.
Good morning, Anvita. How's your health?
I'm better, sir.
Very good. Because if your health is not good, I would have scolded you. But without like considering your health issue, you are forgiven again.
Thank you, sir.
So we are doing gravitation and comparing with the electrostatic wherever possible.
Okay.
Uh, recently started this acceleration due to gravity. You know, acceleration due to gravity, A will become G here. Normally, formula is force is equal to ma. And if you apply gravitation field, it is force per, acting per unit mass. So G value, you know, Gm by R square for a given planet.
Yes, sir.
Okay. And then you can tell same thing in the form of the density and remaining stuff. I'll tell you in the end, both of you, Barinder and Anvita. Okay. Ask me at the end of the class. So Jordan, we were doing this delta R by R plus delta rho by rho. Any doubt?
No, sir.
Okay, so remember, if you have a given formula and you want to calculate percentage change, numerator will be addition and denominator will be subtraction and power will be multiplied. Any doubt? Let's do question, then we'll see the changes in the G value. So if, write it down, if the mass of Earth increase by 2% and radius of Earth decrease by 1%, what will be the final change in the G? Apply same formula, we know G is equal to Gm by R square. Okay, and
Sir,
if
approx 25, 24%.
24,
Yeah.
okay, check it again. So if any change is less than 5%, what will happen? You want to calculate the delta G by G, delta M by M minus 2 delta R by R. Correct. Here, percentage change in the mass is 2 and percentage change in the radius is 1. So, delta G by G. If you see the percentage change, what will you do? You will simply just take the value. Mass is increased by 2%, so 2% minus 2. Radius is decreased by 1, so decreased by 1%. Yes or no? Delta G by G and 2 percentage will be, yes or no? Any doubt?
Got it, sir.
No,
Remember, because R is decreasing, that's why you will take minus, and mass is increasing, that's why you will take plus. Any doubt? So, Barinder, from where you started, like joined today's class, कहाँ पे थे उस moment पे हम?
sir, G is equal to.
So, I'll quickly revise for you guys what is a G, because in variation with the height, depth, and rotation, we need this formula again and again. Okay, so I'm just quickly revising what we did. Okay, what is it? We know force is equal to ma, and in acceleration due to gravity, it will be equal to mg. Yesterday, we did gravitation field, and gravitation field that say that ki gravitation field will be equal to how much force is exerted on the unit mass. So according to this, mass will be mi. Okay, it is same as how you do in the case of electric field. Electric field is the force exerted on the test charge. So force become Q into E. If both value are same, from equation 1 and 2, you can say mg will be equal to mi, cancel, g is equal to I, and you know I value is equal to gm by r square. Remember, this is the mass of the planet and r is the radius of the system. So you will take m mass of the system or planet and r radius of the system or planet. Okay, let's do variation part. First, if you increase the height, what will happen? Variation in g with height. By the way, in both the situation, it will decrease. But how it decreases, let's see. For example, you have Earth. Earth radius is r. Earth radius is r. And now you are observing at some height h from the Earth. Correct? We want to see what will be the gravity at h height. You know normal g value is equal to g m by r square. Correct? But at h height, g mass is same of the Earth, but this time you are calculating total distance, and total distance is r plus h. So this will be r plus h whole square. Correct? We want to see variation. You take their ratio at h divided by g. So if you compare GM will be cancelled out. It is inversely proportional to the r square. Any doubt till here, guys? Any doubt? Because g inversely proportional to the radius or distance. Yes or no?
Yes, sir.
If you take common value r square in the denominator, here it will be this. Other. Any doubt? Keep asking, otherwise you will have more confusion later. Any doubt? Anybody?
No, sir.
R square will be cancelled out, and we say GH by G will be equal to 1 plus H by R. 2 will go up, minus 2, because it is the same like this. 1 plus H by R whole square. Any doubt? You know what kind of question you will get? Most of people ignore this value and they take binomial. expansion. And binomial expansion work in most of the situation, but not always. Again, this is universal. It will be easy to do. If you have simple number, you can apply this. Okay. But if you have to do binomial expansion, remember binomial expansion work only when uh, there is only 5% change, like very less radius. Like R is very big, H is negligible, not even 5%, then you can ignore the H value. Okay. So in this situation, if you do binomial expansion of this part, -2. So if you, Chandana, what will be the value by binomial expansion of this 1 plus H by R whole -2 approximately? This 2 will be multiplied. Yes or no? Power will be multiplied in -2. Yes or no? But remember, this is applicable only when H is way, way, way less than the R. Only in this situation. Otherwise, it is not applicable. Then you know what will be the value. If this is the situation, your G as given height G 1 minus 2h by R, extremely important. I think this is very, very, very important. But only when this is applied. Otherwise, this is perfect. No exception in this. No exception in this. Always apply this and see what is the H value. Example, Earth radius is 6,400 kilometers, and you are measuring gravity at 100 kilometers. You can neglect. But if you are measuring at 3,200 kilometers, you can't neglect this. Understood? So always apply this question with caution. Be cautious about where you are applying this formula. Always apply this and see what is the situation. Okay, right question. At which height from the Earth surface G value become 1/4 time of the Earth G? At what height G dash will be G by 4? I will write. At what value G dash will become 1/4 of the G? You have to calculate height. Here you can't neglect H value because you don't know H value. Okay, that is why I gave you this question. Whatever you do, don't neglect H or don't take H is greater than R like this. Because I know this chapter is easy, you will be able to solve this question, but I also know where you can make mistake. do it and tell me answer. Sarah, you tell me answer for this question.
Sir, height is equal to R.
Height is equal to R. Very good. This is correct. And also, you have to write notes, no doubt about this. But at the same time, at the end, I will check your notes. I will see everybody's notes. Then, if there is any thing like you wrote less, I will write in the group that you did this less. Remember this. I will write in the group. You didn't solve many questions what I taught during the class. And you should solve question by your own. Even if it is mistake, no problem, you can cut it. But solve every question we are doing in the class. I will observe, I will check everybody's notes during class, and then I'll write remark in group. Okay. So if we see g dash by g, it will be equal to r square r plus h whole square. And this is value is equal to 1 by 4 because g dash is equal to g by 4. Correct? Then if you take this, you can also take simple cross multiply. 4r square is equal to r square plus h square plus 2rh. Correct? Can we take this? Take this to the another side. 3r square is equal to h square plus 2rh. Can we do this by this method? Yes or no, guys? 4r square, r square plus h square plus 2rh. Or can we do one thing to make it easy? Take under root other side. Sarah, this is how you did? Took under root both sides?
Yes, sir. Sir, I took
If you,
under root 1 by 4. Then 1 by 2 is equal to r square by r plus h.
yeah, now it will become easy. 2r, r plus h. So it will be r is equal to h. Wow. Everybody did this?
So can you scroll up
Yes,
one?
sir.
Yeah, so thank you.
Yeah. Anybody have doubt?
No, sir.
So
No, sir.
let's do. Jordan, are you writing? Because you are in car.
No, sir. I'm not writing, but I'm watching the way we solve.
Uh, Next topic. Variation in G with depth. Variation in G with depth. It means inside the earth. Correct? So, example, here you can take in two way. You can take density form or you can take uh, R form. It's your choice how you want to take. But you know how we did in the last class, where is the comparison? Hollow sphere, solid sphere. So if you see this solid sphere, complete topic. You can see if you take special case of inside this, correct? This special case inside this, what will happen in this situation? It directly depends upon the R. Same electric field directly depend upon the R. Normally, whether you take gravitation field or electric field, it inversely proportional to the distance. As simple as that. But inside the Earth, it directly depends upon the R. Even same thing happen for the electric field. Electric field directly depend upon the R. Any doubt, guys? So first
No, sir.
note this down. Only internal case. Only case third. This. When you are taking inside. Okay, example, this is the radius of the body and you are calculating only for this part. So this is R and this is small r. You are calculating for this part. If we are done with it, now it's easy for us to solve. But if you didn't, let me know. I will give you time to write.
So can you just show it for a second?
1 second is done. Should I scroll
Yeah,
down?
sir. Done.
All of you are done with this part.
Yes, sir.
Okay. So we know G value is equal to Gm by R cube into R. Remember, capital R is the radius of Earth and small r at a given point. Okay, at any given point from the center of Earth. So again, you have to make diagram here. No, I have to make please. Huh. So if you take this full as radius and you are calculating at this distance, small r. So if you are calculating G guys here, there will be one situation. This is R, but what is the depth? What is this depth? Can we say R minus D? No. R minus R, correct? This is the depth from the surface, and if you uh, calculate from the center, this is the value. It's your choice from where you are calculating. Any doubt?
No, sir. No, sir.
But you can take the another way around also. If this is the depth, then can we say this will be R minus D? You will be thinking, sir, why you are changing again and again? Because here you will be confused a lot. I still remember uh, when I was preparing for NEET, I used to confuse from where I am observing. Okay, from where I am observing. And that's the reason why I'm changing it again and again to get you the point. Tell me, is it like looking really difficult or you can understand everything? Parthia, any doubt?
No, sir.
Varinder,
No, sir.
Vandana,
No, sir.
Sarah,
No, sir.
Jordan, and Anvita.
No, sir.
No, sir.
Okay. So, if you know this, can I say your Rg value will be equal to Gm by R cube? It is R minus D, where D is depth from surface. D is depth from surface. Correct? Right? D is the depth from the surface. Right? And what will be the value at the surface? This is D depth. Normal value. G value we know is equal to Gm by R square. Correct? Now, if you compare these two, how will you calculate G at given depth by G value equal will be? What will be the GD value? Gm by R cube R minus D. What will be the G value? Gm by R square. Correct? So this R square will be cancelled out with this. Gm cancel. Can I say GD by G will be equal to R minus D by R? Yes or no? Will it be also equal to 1 by D minus R? Any doubt? Also
No, sir.
compare with the height. In case of height, when you calculated G as a given height by G, it was equal to 1 minus 2h by R, but only when R is much greater than h, correct? But this is valid for any depth. This is the biggest difference. Valid for any depth because this is the right formula. When you take this from minus 2h by R, this is what you can say a special case. Makes sense? This is special case and depth is the real formula. Got it? If you calculate change in like in both the situation, if you calculate what is delta G by G, so it will be G at the depth minus G divided by G. Yes, correct? Yes or no? It is equal to GD by G minus 1. GD by is this, correct? Minus 1. What will be the value? R minus D minus R divided by R. This cancel. It will be minus D by R. Yes or no, guys? Yes or no?
Yes, sir.
Why we are getting minus sign, Barinder? Maninder, why we get negative sign? The reason is because gravity is reducing. Even before H, we have negative sign. What does it mean? Gravity is reducing, correct? If you calculate 1 minus d by r, negative sign indicate gravity is reducing. In this, gravity is reducing. Any doubt, guys?
No,
Calculate
sir.
delta g by g for the height. Delta g for the height divided by g. What was gh by g value? If we take normal case, then gh by g value was r square divided by r plus h whole square minus 1, correct? And if you take special case, if delta h, like height is very less, then you can take delta g by g is equal to 1 minus 2h by r, correct? This was the gh by g and the whole value minus 1, correct? So can we say it will be equal to minus 2h by r? Yes or no, guys? This again, negative values show that your gravity is reducing with the height. Okay. So if I conclude both height and depth, now we have to compare what happened in case of height and what happened in case of depth. First point, if you calculate at height, gh by g will be equal to r square divided by r plus h whole square. Here gd by g will be equal to r minus d by r. This was the value, right? Correct? Yes or no? First comparison. Second, if uh, you take ratio, then it will be equal to 1 plus h by r whole power minus 2. Here gd by gr g will be equal to 1 minus d by r, only power 1. Any doubt? If you take binomial expansion, and only when r is much greater than h, then this value will be equal to 1 minus 2h by r. But only in this situation. This is universally same thing. This is universally same thing without any special case. Okay. And last, if you take change delta gh by g, it will be equal to minus 2h by r. And if you take delta gd by d by g, it will be equal to minus d by r. Yes or no, guys?
Yes, sir.
We made summary of what we did in the last two topics, and you can compare. Can you also say if you take height and depth, h is the height above the surface, d is the depth below the surface. This is also important. Key when you take h, example, this is the radius r. Here you take height from the surface h. Here you take depth from the surface. Example, this is d and this is center total r. Then this will be r minus d. I think I did not leave a single point of the comparison between these two. And in this situation, you can say if you compare if 2h is equal to d. See, whatever change happened because at 1 kilometer depth, you need 2 kilometer height for the same change. Understood?
Yes, sir.
Because this was one of the NEET question. And almost same curve what we made before, you can say here because we said ki G is equal to Gm by R cube directly proportional to the R. When if you take solid sphere, because Earth is solid sphere, and inside. Do you have lot of background noise?
No, sir.
No, sir.
Not at all, or little bit.
No, sir.
No, sir.
No, sir.
Good. Because some construction is going on in nearby area. So what happened? You can see G is directly proportional to R at point where R is equal to capital R. And after that, it will reduce. Right here, G is inversely proportional to R square. But before that, G is directly proportional to R. Correct? Then here, G is equal to Gm by R square. Any doubt?
Yes, sir.
Please, because NEET do not ask much question on the rotation. Rotation, if we give less time, is absolutely fine. But height and depth is very popular question. Extremely popular. Let's solve question, guys. Then seriously, you're not getting on a small noise, background noise.
No, sir.
No, sir.
This is the power of earphone. Wow, no background noise. So this is PYQ actually. A body weigh 72 Newton.
Eight. Eight.
Somebody Somebody's mic is on. Is it Sarah you?
No, sir.
Okay, it is taken to a depth. Keep writing question equal to r by 2 from the surface of Earth. Remember, you will do mistake from where you are calculating t, and I will mention this again. From this surface of Earth, and of course, Earth radius is r. It would be weight. What will be the weight? Okay. Remember, d is always taken from the surface. I will write it here again. D taken from surface, not from center. D is taken from the surface.
36 Newton.
What? What is your answer?
36
Pratigya?
Newton. 36.
36. 36 Newton is correct. In case of depth, formula is universally fixed. Example in height, if you take r by 2, then you have to take formula only this. Uh, r square, r plus h square. This is the correct formula. But in case of depth, it's easy. G dash by g formula will be equal to 1 minus d by r. Okay. Your depth from the surface, depth from the surface r by 2. Remember, from the surface. Even from the center, it will be r by 2. So r by 2. 1 minus half will be that. If you multiply by m both sides, this is the weight. Mg dash will be mg by 2. Mg value is 72. Okay. Any doubt, guys? Any doubt? Anybody have doubt?
No, sir.
No,
No,
sir.
sir.
At what depth from Earth's surface G value decreased by 75% of, yeah, that's all. Where G value will decrease by 75% of total G, like original value of the surface. No. Chandana, in this situation, what will be the G dash value?
Sir, 25.
25%. Because it reduced by 75% remaining is 25. So can we say G dash will be equal to G by 4 because 25%. 25% of G. Correct. Now you can calculate G dash by G at the depth is equal to 1 minus D by R. You have to calculate D value. This is equal to 1 by 4. Correct. So it will go to another side. 1 minus 1 by 4 is equal to D by R. It will be D by 4 or it is correct.
And my answer is 5952 kilometer.
5, 9.
That's my mistake, my mistake.
If you take in the kilometer, like you have to put R value 6400 kilometer.
No, sir.
Otherwise,
I just 75%. I will take 7%.
okay, you took 7%.
Yes, sir.
Wow, you are best, Pratigya, best. Next question. Question number 6. Anvita, at you have to solve this question. At what depth from Earth's surface G dash will decrease by 2%? You have to use this formula. Yes. Who are left from question? Jordan, you right? You didn't answer the question. Jody, Jody.
So
Is
he's
he
not
there?
there in the class.
Okay. Wow. Sarah is twice. Jordan is not there. Sarah, you are completing the quota of Jordan.
Yes, sir.
Yes. Anvita, what is your answer? What is your answer, Chandana, Anvita?
So one
After that, I'll finish this topic. Only small part is left for gravitation. In next class, we'll finish this chapter. This chapter. Even if I have to take at 9:30, I will take, but I'll finish this chapter tomorrow at any cost with
so
questions.
is it 0.20 something?
0.20.
I don't know. I did something wrong, sir. Can you explain?
So D value will be equal to 2 by 100 and R value is 6400 kilometer, 128 kilometer. You can write 2 by 100 R or you can put R value. It's your choice. Okay. I ask question from everyone, like one question. All of you are done.
Yes, sir.
Then next topic is variation of Z due to Earth rotation. Variation of G due to Earth rotation. So when Earth rotates, then definitely G value will change. What is the change? For that, you need to understand how Earth rotation works in normal situation. For example, if you take this Earth surface, then this is rotating, Earth is rotating, and if it is rotating, there will be some angular speed omega by which it is rotating. Correct? If it is rotating at any point, example, I will take this. This is the center of. Correct? If you calculate at this point what is the rotation, what will say ki it is making some angle with the equator, some angle with the equator. Okay. Remember, omega is the angle of rotation at what angle it is rotating. Correct. If you see at this point, outward force will be mv square by r. Here you have mv square by r centrifugal force. Correct. Here, if you take, if this is lambda, this is also lambda angle. This is normal. Correct. Normal at the outward direction. Radius is r, and in this rotation, if you take this axis of the rotation, let's take this value is small r. Any doubt, guys, till here? Because not many questions asked from here, but you should understand rotation through this. Okay, you should understand rotation through this. Any doubts?
No, sir.
So if you don't have any doubt, can you say normal is acting in the outward direction will be equal to inward direction will be mg minus mv square by r if you take the complete earth at some angle cos square. Understood? Why? Because this side will be cos theta, another side will be sin theta, this will be cos lambda. And because here you take square form, that's why this. This n will tell you the effective gravity is equal to mg. And if you convert this, v is equal to r omega. So omega is equal to v by r. Correct? V by r. So if you put uh, v is equal to r omega, instead of V, you can put R omega, so it will be M R square omega square R cos square lambda. Ask me question, guys. Any doubt? Any issue with this? You do have a lot of issue actually. You don't know what is this G effective, what is this G. Remember, G effective is the gravity during rotation, and G is the gravity without rotation. And cos square lambda we are taking because it is rotating at some angle. Right? It is rotating at some angle. That's why we are taking cos aspect this aspect. Okay? Because if it is mv square by r, its connected component will be cos theta. Another side would have been sin theta. Tell me, guys, any doubt? Look better.
Sir,
Yes, Pratigya.
sir, why you take lambda instead of theta?
What?
हम थीटा भी ले सकते हैं ना लैम्बडा की जगह.
थोड़ी सी वॉइस ब्रेक हो रही, दोबारा बोलना, मैं आवाज को बढ़ा देता हूँ.
सर थीटा के बदले लैम्बडा के बदले थीटा भी ले सकते हैं ना.
अरे ये लो, तुम्हारी ख्वाहिश तो पूरी कर देते हैं. क्या छोटी बात
सर
है.
लैम्ब
सब ठीक है, खुश हो.
नहीं,
एंड वाई खुश नहीं हो?
मतलब
तो देखो,
डाउट अब दिक्कत नहीं है.
हाँ, चलो तुम खुश हो जाओ. एंड वाई वी आर टेकिंग दिस? बिकॉज योर आर वैल्यू विल बी इक्वल टू आर cos theta. So your r square value will be like r square cos square theta, like this. Look better.
Yes, sir.
It look like we are so habitual to theta, we don't want to see any other thing, right? Correct. That's all. Because here you don't have any big formula. You can cancel m because m is the common. So gravity after rotation will be less than the actual gravity. Mass remains same, moving with the same angular velocity. R is fixed. What will change? Only theta will change. That's all you need to consider. Not many questions asked from this, though it is part of our syllabus. But you have to understand only theta will change during rotation. Everything else will be same. Correct? And there could be two extreme situation. If theta is 0, then cos 0 value will be 1. And if theta is 90, then cos 90 value will be 0. If cos 90 value is 0, then here G effective will be equal to G. Correct? Here G effective will be equal to G minus M omega square R. Correct? So you will see this situation that your uh, gravity will be maximum at the pole and minimum at the equator. Because when you take theta 0, then it will be pole. No, my bad. Equator, na?
Sir,
Equator. And if you take theta 90, this will be pole. How do we know? Because this line is known as equator line. This line is known as equator line. Correct. This line is known as equator line. And what is the pole line? This one. This is known as pole line. So at pole angle is 90 degree. This theta will be 90 degree. At equator it will be 0. Yes or no, guys?
Sir, I have one doubt.
Yes, of course. To ask.
Sir, in effective gravity,
Uh,
that is capital M or small m, sir? M is M.
M is the mass of the Earth. Doesn't matter.
So, like in the above step,
Uh,
can you show that above step?
you are thinking we have to delete this now.
Yes, sir.
Yes, you were right. Thank you for telling this. This will be minus. This will be minus because M are cancelled out. Right? Yes. Good. Any doubt, guys? We are simply saying that gravity will be affected at the end. Gravity will be maximum in case of pole and minimum in case of equator if everything else is same. This is pole. This is equator. Any doubt? Can we say if you go from equator to pole, your weight will increase because G value is increasing? So question can be asked in the assumption region. If you move from equator to pole, then what will happen? G value increase. If you move from pole to equator, then G value will decrease. Tell me any doubt? And this question already been asked in the only theoretical question. That's why if you want to release anything from the Earth's surface, example satellite, you want to release it from the equator because in case of equator, gravity is less. We need to provide less fuel. Make sense?
Yes, sir.
Okay. Last thing is shape. Just give me 1 minute. I'm coming back and I'll finish this topic. Then we'll solve this. How is it going as of now? Does it look difficult, easy, or medium?
मीडियम एंड डिफिकल्ट के बीच.
Huh? Is it difficult?
मीडियम एंड डिफिकल्ट के बीच.
No, 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 no. It should be between medium
Zero.
and easier side. Ah, but it's okay if it look between medium and difficult. I have this responsibility to make between medium and easy. Okay, see one thing. If this is the normal formula, uh, you know what happened in the pole in case of equator. But if nothing is mentioned in the question, you will always assume object at equator when theta is zero. Understood? If not mentioned in question, then why I'm writing equation? If not mentioned in the question, then you will always take theta zero, and your in case of zero, your g effective will be g minus omega square, correct? If not mentioned. Any doubts?
No, sir.
No, sir.
No, sir.
But tell me, who will tell me? Pratigya, if Earth suddenly stop rotating about its own axis,
Yeah.
what will be the impact on the apparent weight of the bodies? Weight or g? What will it increase or decrease?
Sir, again, please repeat question.
If Earth stop rotating about its own axis, about its own axis, what will be the impact on g? Then
Increase.
your then your omega will become zero. Then g effective will become g. Automatically it will increase.
G G equal G equal रहेगा हाँ हाँ पोल में
G
increase होगा
is always remain same. G effective will increase, right? Because initially it was minus, now there is no minus, so automatically it will increase. Okay, any doubts? Last point, and then we'll be done with the variation. I will try to do the summary, the full topic. Just because you, Pratigya, mentioned between difficult and medium, you are responsible for this. Variation in G due to shape of the earth. We know, we consider is sphere, but actually it is not completely sphere. It is geoid, right? Egg shape, kind of egg shape. So what happened in this case? There will be slight variation. Why there is a slight variation? Because Earth is not perfect sphere. So if you are assuming it as sphere, then your value will be different. Correct? There will be very, very, very small difference. You can neglect it, no doubt. But you know, gravity at the pole will be more as compared to the gravity at the equator. We did this. The gravity at the pole is greater than the gravity at equator, right? Because of the rotation. So it means, but if it is spherical, then gravity should be same at both the poles. This is gravity at equator. This is gravity at pole. Both should be same, but here it is not same. What does it mean? It means Earth is not perfect. Pole have more gravity than equator. That's it. Any doubt?
No, sir.
No, sir.
No, sir.
Now I'll give you quick summary of what we did today, and then you will share your thoughts. First, we said acceleration due to gravity is equal to gm by r square. It depends upon the radius, directly depend upon the mass. If you take mass and instead of mass you take density, it will be gr flow, directly depend upon r. If density is constant. Because in case of r, density remains constant. Okay. First situation, because of the height, if you compare new gravity compared to the old, it inversely depend upon the uh, height or r. That's why g inversely depend upon r plus h the whole square, and it inversely depend upon r square. Correct. And if height is very less, then it will be equal to 1 by 2h by when h is very less than. Second, if you take depth d, then again it depends upon the depth. So it will be r minus d by r, or equal to, not approximately exact, equal to 1 minus d by r. And it is applicable for every situation, no exception. Okay. Same way you can calculate delta g by g, here will be equal to what by r. Delta g by g will be equal to third. What is the impact of rotation? Impact of rotation is explained by g dash will be equal to g minus omega square r cos square theta. Okay. So theta have two possibilities. Theta will be 0 in case of equator, and theta will be 90 in case of pole. Right? If you take at pole, cos 90 we know is 0, then g value will be maximum. G dash. Here cos 0 is equal to 1. G dash value will be minimum. Correct? So it means gravity at pole will be greater than gravity at equator. That this was the summary. Tell me, guys, was this summary really easy and simple to understand?
Yes, sir.
Yes, sir.
Yes.
Agar Pratigya, if you tell me, कि sir, this is medium to difficult, I will, I can do one murder, because one murder is allowed for me as a teacher. Tell me, three, I got three,
Wait.
Sara, Chandana, and Barinder, yes. Pratigya,
Yes, sir.
कैसा लगा? बहुत tough है sir, बहुत. It's a very tough, sir.
Yes, sir. You are great.
Anvita,
हाँ सर ठीक है.
not easy.
Not right now. I will not say it's easy right now. I need to study more. Practice more.
That was the summary of today's class. And you have to solve 20 questions from this. And now using this formula, you can solve any question. I think we have more than, where is Nihal? Study gravitation. I will tell you how many questions are there in this. Acceleration due to gravity from 14. From 14, 15, you can solve question up to 24. 11 questions are there. We did this universal law also. We did first 20, first 24 question we completed. So today's task is to complete first 24 question and starting from 14th, not 14th. You have to do yesterday's work. Huh? 10 to 24 first and then last night. Okay, this is what we need to do. Need to do. Wow, wow, 66. That means 42 more questions. 24. Okay, it means we have to do more work. Probably I'll take one evening class from the gravitation chapter. So you don't get stressed for tomorrow because tomorrow is test. You will have in 11th physics is almost done now. First chapter is done, second, third, fourth, fifth, sixth, gravitation is done. Seventh is left, thermal property, thermodynamic, kinetic theory of gas oscillation. So basically, two chapters are left from 11th, solid and fluid and waves. Okay. By the
So
end of
when
this
do we
year,
have the class?
evening, 2 o'clock and 5:30 classes as usual.
Okay.
Evening class I'll plan around 9 o'clock. Okay, send me quickly your notes and solve these questions. Send me these 14 to 24, 11 questions. Before 2 o'clock, send me these 11 questions.